What is the percentage of decrease from 12 to 4?
12 to 4. Okay, I can do this one. We want to know percent decrease. So anytime you're finding a percent change, I'll just maybe give a formula to start with, and then I'll talk about why it is what it is. So anytime you're finding a percent change, you want to, you're finding a percentage from the actual change from out of its original value, out of the original value. So right now, it went from 12 to 4, and so our original value would be 12. So that is our original. And then the actual change is how much it changed. So the reason why the formula is this is because we're comparing how much, like the actual amount that it's changing to what it started as. So, and that's going to give us what our percent change is. So to find the actual change, or how much it changed by total, you're going to find the difference between the two quantities. So in this case, if I went from 12 to 4, it's changing by 8, because 12 minus 4 is 8. So that's the amount that it's actually changing. So it's going to change by 8 out of, and then our original value, which is 12. So that is our fraction of the amount that it changed, so 8 out of 12. And then we're going to turn that to a percent, so maybe one of the ways to do that would be to turn to a decimal first. And so I'm thinking this as, this is the same if you think of this as, it's 2/3, really. 2/3, which is 0.6 repeating, which if we were to convert that to a percent, we're just going to move our decimal point 2 spots. So we have 66.6%, so we'll round up to about 67%. So if you go from 12 to 4, there's a decrease of about 67%. But this is really, I don't know, I always just try to remember this formula because percent change comes up a whole lot. And it's just your actual over your original, your actual change over the original value. Do you have anything to add to that?
I usually do recent value minus original value divided by original value. I mean, it's the same thing. Mm-hmm. The reason why I kind of like doing that is when you have a decrease, it's going to be negative. And it just kind of reconfirms. But I also think, like, I have some students that get a little hung up on, wait, which should I do first? Or which should I put in the denominator? Mm-hmm. And I think sometimes it helps to see, were you writing that down? Or
I just wrote decrease, like as opposed to negative. So would you say, like, I wouldn't say, I could either say negative 67%, or I could say a 67% decrease. Correct?
You wouldn't say a negative 67% decrease, because that's
right. I would just say a negative 67% change.
Yeah,
right?
Yeah. I think sometimes my students sometimes get hung up on what should I put in the denominator. Mm-hmm. So I think it's sometimes helpful for them to see. Let me see if I can just do it really quick. You could put percent change, and again, this is the exact same thing that Becka did. I just kind of write out the equation a little bit more. You can do final value minus initial value, and then you're always dividing by initial. Mm-hmm. But again, same thing, because what you're doing when you do the final value minus the initial is the amount change. Mm-hmm. But I don't know, just sometimes sometimes students get hung up on what do I have to subtract from what. It doesn't really matter, actually.
Right.
You just have to know
know if it's increasing or decreasing.
Yeah.
In the end. Okay, cool. Wasn't sure if there was anything else we could add, but